In this video, we're going to learn about dimensional analysis. Dimensional analysis is a technique that we can use to convert among different units and also to solve some simple algebraic equations. Now this question right here is something you might be able to do in your head. Oh, 2.5 times 60 gives us 150. But what you're doing in your head, I'm going to show that in dimensional analysis just so that we have an idea for when we get to harder problems. We take that initial 2.5 minutes and we're going to multiply by a conversion factor that will get us to seconds. Now I know that in 1 minute there are 60 seconds, and so what I can do is put in this conversion factor as such, and note that if I multiply minutes times seconds and then divide by minutes, the minutes cancel, and I'm left with seconds on the left and the right side. This tells me that I'm doing the problem correctly, and now at this point, I can start playing with the numbers. Oh, 2.5 times 60 divided by 1 is the 150 seconds that you may have predicted at the beginning of this problem. Let's go to something a little bit harder. How many hours are in 2 weeks? Well, I'm going to start with the 2 weeks, just as I did before, and I need to multiply by some conversion factor that will get us over to hours. Now, the trouble here is, I don't know how many hours there are in a week. If I did, I could do this in one step. But what I'm going to do instead is I'm going to say that there are 7 days in 1 week. And from here, after canceling out the weeks, I now have to get to hours from days. I can say that there are 24 hours in 1 day. And the days now cancel. And I'm left with hours on the left side and hours on the right side, meaning that I've done this correctly. So now I can take 2 times 7 divided by 1 times 24, divide that by 1, and I get 336 hours in 2 weeks. I mentioned before that we can use dimensional analysis to solve simple equations. Density is equal to mass over volume, and I can use density itself as a conversion factor. So if I know I've got a piece of aluminum with a volume of 2.0 milliliters and I know its density, I can find its mass as follows. I can start with my 2.0 milliliter sample of aluminum, and I'm going to multiply by density as a conversion factor. I'm going to say 2.7 grams of aluminum exist for every 1.0 milliliter of aluminum. And if I'm solving for mass, the milliliters cancel out, and I get grams on both sides, which is what I want. I find that there are 5.0 grams would be the mass of this 2.0 milliliter sample. I can also start from mass and go to volume similarly, but by flipping the conversion factor. I put the milliliters on the top, I put the 2.7 grams on the bottom, the grams cancel, and I end up with 3.0 milliliters as the volume of the sample. I'm going to close this video off with a hard problem, a challenge here. We have 3.00 miles per hour is the speed at which we're walking. And I need to convert this to feet per minute. I'm going to give a little bit of space here, but I need to convert the miles to feet and the hours to minutes. So what I'll do is I will say that in 1 mile, there are 5,280 feet, and the miles cancel, and I'm left with feet over hours, but I need feet over minutes. So what I'll do is I'll say that there are 60 minutes for every 1 hour. I put the hours on top, I put the minutes on the bottom, and note the hours cancel, the minutes stay. The last unit standing on the left side are feet over minutes, and on the right side, feet over minutes. That's what we're looking for. So from here, I can say 3.00 times 5,280 times 1 divided by 1 times 1 times 60, and that comes out to 264 feet per minute. And that's it. I hope this video has been very helpful. Please feel free to leave any questions or comments in the comments section below. Thanks for watching.